Hello, hello, hello. Welcome to Vector Space Talks. My name's Neil Kanungo. I'm joined today by Jenny Sigadalskia, DevRel at Qdrant. We are your hosts today. We are going to be talking about our hackathon winners for our Think Outside the Bot hackathon. And let me bring on stage our hackathon winners. We have Sanya Kapoor, we have Abe Singh, we have Ben Council. Welcome to the stage, our hackathon winners.
Everyone.
Say hi, everyone. Welcome. So thank you for joining everyone today, for whether you're joining in the morning, your evening, your afternoon. Thanks for joining our live stream today. We have a few slides that we're going to just kick things off with as we wait for people to trickle in, just kind of get things warmed up. And then we're going to jump into some of the cool projects on the Think Outside the Bot hackathon. So without further ado, let's get started with Vector Space Talk. So I wanted to let everyone know about our Qdrant Stars program as we get started today. Our Qdrant Stars program, if you're interested in being a community leader in Qdrant, our Qdrant Stars program is a community advocacy program where you can earn rewards. You can get paid to travel and do events and get swag and get highlighted and spotlighted in the community. Become a star in the community for contributing content, for creating tutorials, for doing meetups and hackathons. So if you want to become a star, check out Qdrant Stars on our community website. It's a great program. We're growing this program very actively, and it's a great way to participate and lead others in the usage of Qdrant in our community and help others with Qdrant. So wanted to highlight that. I also wanted to just talk about our Discord community. Please join. We have over 8,000 members. We're growing every month. Forgot to update this slide. Our next office hours is actually next week, not September 18th. But our next office hours is next week on Thursday. Jenny will be there. I will be there, and we will have a virtual live Discord office hours where you can come chat with us live. We're bringing people from around the world to talk about their projects. Just as Jenny likes to say, we will yap, and it's for yapping. And we will talk about all things vector search and AI. So join our Discord if you want to be involved in our digital community. And I also wanted to let everyone know about Qdrant Cloud Inference. As of this week, Qdrant Cloud Inference is becoming available on all regions and on the free tier of Qdrant Cloud. You will have free credits to run Qdrant Cloud Inference. So applause for this. You can now use Qdrant Cloud Inference with the free tier. Use it with various models. We'll be adding new models to this, and you can use this globally, on whichever region you're in. And with that, I just wanted to say that we wrapped up a couple weeks ago our very first conference, our Vector Space Day. We had great participation from many partners. We had almost 400 attendees. This was in Berlin on September 26th. And we had great speakers. We had 3 Qdrant Stars speak. And we had about 25 speakers. We had several lightning talks. We had breakout talks. We had food. We had prizes. We had a DevRel desk. It was a great time. And we're looking to continue this in future years, in the following years. But it was a great time. But one of the things we did in this Vector Space Day is we talked about our Think Outside the Bot hackathon. We announced the winners of the Think Outside the Bot hackathon, which we're going to go into today. And the Think Outside the Bot hackathon was a challenge to build an application that was beyond a RAG chatbot. We see a lot of vector search used for RAG chatbots, but how do you do something beyond just a RAG chatbot or conversational interface? How do you think outside that and build something that's truly creative and novel? And we challenged our hackathon participants globally and digitally around the world over a 5-week period to build something that could truly impress us. And we had many great submissions. We had many sponsors that you can see at the bottom for some side prizes. And we had some main prizes as well, where we had Ben, Abe, and Sonia all win our third, second, and first place prizes. And I'm pleased today to go over the hackathon deep dive. So with that, I'm going to actually hand over to Jenny and Abe to talk about the first award, which is the third place winner with AI spatiotemporal intelligence. So I'm going to hand it over to you two.
Yes, it's super exciting. Firstly, everybody clap once again. That it was super cool to judge it. I saw so many things that I wouldn't be able to do myself. I didn't say that, but this is in life, so guilty. Everybody have heard that, and I am super curious to see once again go over your solutions, guys. So we will start with Ape, and I am really, really looking forward to the demo and the motivation and how you figured out to do all of this stuff together. Because Ape here, he had the solution where he introduced to NPCs in Unreal Engine game the ability to remember locations, so to have a temporal memory of the proximity of the objects. And this is somehow a future of our gaming. And in general, it's super interesting to see vector search in gaming industry. So please start and tell us everything, and then we're going to ask the relevant questions, and in general to see how did you come up with such a, well, I would say interesting project. And I will be very much looking forward to figure out how you managed to make it so lightweight, as you told me.
Yeah. So hello everyone, I'm Abhay, and for Vector Space Day Hackathon, I built this project called NPCs with spatiotemporal intelligence. So the problem with current NPCs is that they are driven by behavior trees. So basically they are scripted and they don't have memories of anything, and they can't see or hear and can't reason. And the worst of all, they don't have a word model like NPCs should. So we basically went on to solving this. And so there are two main parts in our solution. One is conscious brain. For that, we used GPT-OSS 120 billion, which is a 5 billion mixture of experts. So it's pretty fast. And for subconscious brain, so this thing will have memories. We used Qdrant. With that is a very efficient and fast vector search engine. So our NPCs have basically
right here and just say NPCs for those that don't know, non-playable characters in video games.
Yeah, so yeah. NPCs mean non-playable characters. So those people will wander around here and there.
Yeah, when you go talk to a character and they just kind of repeat themselves like, mindless zombies in a game. They just kind of say the same things over and over. They're unscripted. So you're giving them some actual personality, some memories, some real behavior, like real intelligence to interact with.
So we basically have two collections in Qdrant. One is image memories. So like remembering that old bridge when an NPC sees it in game. So that collection's payload contains the location, direction in which the NPC was seeing, and the timestamp. And there is another collection called event memories that stores the major events that have happened between the NPC and the surrounding world. So our NPCs for senses, we are using Whisper CPP, and that's a very lightweight 72 million parameter model which runs on CPU, and we are using 5-bit quantization. So it's like 60 MB on RAM and doesn't even use GPU. And for vision, we use Liquid AI's Liquid Foundation model. That is a 450 million parameter model. We also use the 4-bit quantized version. But this is the only thing that we run on GPU. And for speech, we use PiperTTS. And we implemented all these things with Unreal's custom C++. And now onto memories. So for image memories, we basically have to use something that shares the space between text and vision. So the textual understanding of an old bridge should actually match with an image of an old bridge. So when NPCs creates memory, then it just uses the image from the NPC's camera. But when conscious brain needs to load in a memory, specifically an image memory, then it can query by things like an old bridge, and that thing will be passed via the text encoder, and our 512 dimensional vector will be outputted, which we match to the stored memories to fetch in if we have any. And for event memories, actually we extract this using during the sleep cycle. So I wanted to replicate somewhat of how humans consolidate memory in their sleep. So the whole conversation gets passed on to a chat completion, and major events are extracted from the conversation. And those events are embedded using this sentence transformer. It's also a very lightweight sentence transformer and runs on CPU via ONNX runtime. And we actually we met with a problem that the Hugging Face tokenizers isn't really available in C++. Actually, it's written in Rust and is available in Python. So to make it available in C++, we had to write a custom Rust library using its foreign function interface to access that in Unreal C++. So yeah, now NPCs can remember things like when player finds a rare item in a basement, then yeah, things like that. And now you may ask, why is this even viable? Well, nowadays the major bottleneck is always the GPU. So games run at 95 to 98 or 99% even usage of GPU, while only utilizing 25 to 30 or 40% of CPU. So we thought that CPU optimized pipelines could be used to upgrade NPCs to new level. In our pipeline, everything runs on CPU except the 450 million vision model that runs on GPU locally, and that LLM which runs on cloud. It acts like a conscious brain. And here is a demo. It actually is running on a very low end device. I hope it.
This place is beautiful.
It really does have that snuff.
This painting is pretty, isn't it?
Absolutely.
Hey, I'm back. I hope you remember that pretty flower painting.
Hey, of course. It's that dark room piece with the bright pink and white bouquet in a vase. The colors really pop against.
I told you my favorite color, right?
Yep, you mentioned you love purple.
Actually, I didn't include the whole 4-minute demo as that would be too much.
So I really like that because I know that was just a quick preview, but what was really interesting to me was that it showed day 1 and it showed day 2. And while it was just a quick clip, the first day you kind of come in and you show a couple things in the room, you ask about the room, and it's observing the room. But on day 2, when you come in, you say, tell me about that painting. It directs you to the painting. It remembers where the painting was and says like, hey, you can go back to the painting. It's in this other room. And so it has that memories and that spatio-temporal reasoning to like actually direct you to it. It was really cool.
Yeah, so the conscious brain, which is the LLM, has access to the subconscious via tools. So it can use those tools to access memories if it needs to. So when player asks something like, "Hey, do you remember that old bridge?" then it can actually use those tools to carry those image memories and event memories collections.
This is super cool. And how did you come up with the idea? Do you game yourself? Was it like, I'm so annoyed they don't remember anything and it's just super boring, and you're like, okay, let's fix it?
Actually, I always loved gaming, but I didn't really like the way NPCs behave. I mean, they should remember you, but they don't. So I thought, why not make something?
And do you think that this lightweight approach will work also for mobile games, like at some point? If we exclude
At,
the
s-
vision.
at some point, yes, but currently, I think the for low-end laptops, it definitely works.
I would also ask, by the way, I don't know if you finished or not because I am throwing at you so many questions.
Yeah,
So
yeah.
please,
Actually,
it's
that's
going.
the last slide.
Okay, perfect. Then you do it, and then I'm gonna ask like one, two more because I'm super curious.
Yeah. So I think future of NPCs is obviously agentic. I like presently NPCs behave pretty much like this, but I think it's a bit of exaggeration, but in very near future we will see agentic NPCs. And I think because of the subconscious part, the vector search engines will play a big role.
Yeah, I also think it makes a lot of sense. And I actually wanted to ask you how you make a choice that your current NPC should attend memory, and which of them. Is it like now done by the LLM that you are using with reasoning?
Yeah, that's why we use such a big LLM. It decides when to fetch those memories. Actually, the conscious brain will decide if the memory should be fetched or not.
Aha, so it's basically already an agent to some extent.
Yeah, yeah.
And if you would extend this one, that would be probably my last question because otherwise we're going to just stay here on that one. But if you would extend the current application, if you would turn it into an actual game, what would you add? What do you think is now the makes it more a proof of concept, and what is the next big step?
I think first of all, I will embody it, so I will give it its own body and also access to tools like controlling bodily animations, like moving to a certain point, performing some actions, interacting with objects. I think that would add a lot.
Okay.
I was thinking, what about outside of gaming? Do you see applications for this in the real world where you might have augmented reality? I mean, we're seeing Zuckerberg with his AI glasses, and we're seeing more augmented reality, Oculus, Rift, VR glasses and things like that coming out. Do you see any potential for enhancing memory and guidance with using the CPU available pipeline for that?
I think it's a, I mean, not about VR itself, but I think, yes, it can play a big role in education. So, I mean, now those people without VR even can get help from it. But yeah, I think, yes.
Yeah, actually, it might be very interesting application as an aid to people, um, even not for the sake of like fun, but more for the sake of help. That would be
Yeah.
super interesting, especially if it's done lightweight. And I know why Neil asked about VR because I think on the VSD we had the present in our raffle, which was VR glasses. So Neil is trying to combine all the words
I,
together.
I haven't actually bought a VR, but I plan to. So I think I will
Okay,
make something. Yeah.
so it's the next hackathon. We're doing it on
Yeah.
our VR glasses, and they're going to be the prize. I think we have a link to your repo, which should be public. Am I right? Um,
Yes.
so it's accessible,
So
and people actually can go and watch and learn from your doings.
Yeah, we have a blog. If you go to our Qdrant website, it's really hard for us to share links from our live stream unless we prepare them beforehand and put QR codes in. I didn't get this one ready, but if you go to Qdrant website and you go to our blog, we do have our hackathon winners blog post. It's towards the top, and you can find links to all the repos and full videos of these demos that you can go through and see. In fact, I will just show that real quick.
Yeah, let's demo it, because I feel the most interesting part is always to see the GitHub and also know where to look. And I hope everybody can actually access and also ask you questions, because I think there will be a lot of gamers which would like to repeat the same experience, because NPCs piss off a lot of people. So even in real life. Yeah, that would be the third one.
Yeah, so here's the video. There's like a full video here with deeper dive into the demo and the repo as well. And then you can see the first, second, third place, as well as the best in category, Mistral prize, Superlinked prize, 12 Lab prize, etc. And I will try to put this in a QR code if I can figure it out.
Okay, then maybe you could do it actually when we will give the stage to our second place winner, because I think that would be the perfect. Ooh, we managed to do a QR code. You are blazingly fast, Neil.
There we go. It's a
This
new
very
feature.
effective.
Yeah, it's covering my face, but it's okay. It's okay. You don't need
it. No. How could we do that? But I think that we can slowly shift it to Sanya. So
yes,
we can everybody, because every project is super interesting. I know that it sounds super banal that I'm saying that, but I am very sincere, because I was the one judging and I was like, oh my God, what people can do actually out there. And Sanya's project is actually really, really beneficial for us to showcase, because from my perspective is the perfect fitting thing for our Qdrant Edge, which is a little bit of our beta tasting spicy feature, or even I would say a major project which will come out at some point. I would say at some point. So it's about the next stage of vector search, which I expect, and all of us actually expect, moving to lightweight devices, to mobile devices, to lidars, to robots, to basically your Roomba. I'm the person who loves my Roomba so much. That's why it spoke to me, your project, what Sanya has. And I mean, she will obviously explain it better. But as I understood, it's the ability to make your robot to remember trajectories, and like as a memory in our vector search engine, and then use this memory to navigate. So basically it's reinforcement learning reimagined with a vector search in mind. So I'm super excited. Please, Sanya.
Okay, thank you. Hi guys, I'm Sanya. I'm really excited to be here and talk about my project RoboBank. So to start with a little bit about what actually motivated me to make this project. So I've been interested in robotics since the very beginning of my bachelor's degree. I've always found it fascinating that we can build machines that perceive, decide, and act. But what's always bothered me is how fragile these systems can be. Robots are really good at doing what they're programmed to do, but they don't learn from their own experiences unless we explicitly design them to. They repeat the same mistakes again and again because most control systems don't have memory as such, they have rules. And around the same time, I was working at IMI on a Draught AI agent that also used Qdrant for semantic search. So when I saw Qdrant's Think Outside the Bot hackathon, I thought it was the perfect time to actually experiment and do something which I've been thinking to do and finally bring an answer to this question in my mind. Like, can we give robots a vector memory, a way to store and recall experiences just like large language models do? So Coming along more in robotics, most safety systems are rule based or reactive, as I said. So you define safe zones, collision thresholds, or fallback paths manually. That works until something unexpected happens. For example, a warehouse robot might suddenly encounter a misplaced box or an uneven floor. If it's never seen that before, it doesn't know how to respond. Machine learning, of course, helps. We have deep reinforcement learning algorithms now and everything. But the thing is, they take a huge amounts of training data, and it isn't great at remembering very specific situations. So this is how basically RoboBank was born. So now coming on to my core idea, this is basically a small flowchart. Of course, it does not capture and encapsulate everything the system is going on, but it's an easy way to explain what is basically the synopsis of the project. So every few seconds of robot behavior, the sensor readings coming through are basically taken, and along with that, the actions like moving from left to right or straight up going ahead are basically taken and stored as a short memory clip, as a sequence. So now that sequence is converted into a vector, and you can say it's basically a numerical fingerprint representing what that robot felt in the moment. And it's all upsorted into Qdrant. If the clip ended safely, it's labeled as safe. Otherwise, it's labeled as near miss. Or if a collision happens, we directly label it as unsafe. Now, when the robot faces a new situation, it takes its current sensor readings, creates a vector, and carries the vector database for the most similar past experience. Now, coming on to how we actually decided onto what these embeddings will be, which I think is the most important part of this project. So as you can see, there's an equation here. So basically, in our leader sensors, they tell us what is the distance and the surrounding distances which the robot goes through. So these are basically taken in. Along with that, we basically take the velocity, which is the speed, and along with that angular velocity, which basically tells which direction the robot is supposedly moving in. Now, along with that, we are basically taking in 5 time steps, which are basically taken as 5 because I think that's enough to capture a very small action like a robot arm moving, but it does not come and confuse with another action like a robot arm moving and then also going left. So that's why we have taken 5 time steps. Along with that, we take 16 leader arrays, so that comes up to 80 values. Along with that, the action sequences are basically our velocity and angular velocity. So that comes up to 10 values. These are basically concatenated together to form a 90-dimensional vectors. After that, I put them through L2 normalization, so that basically when we are going through similarity searches, it focuses more on what the pattern similarity of the sensor is rather than the scale. Along with that, labeling is very crucial because we need to filter along with like the safety labels. If a collision happens, we do not want unwanted trajectories to be given to our robot. So if I give an example, if the robot's proximity sensor shows a collision threshold or the leader return drops suddenly, it's labeled as unsafe. And if the movement ended with stable control and within a clearance margin, then we can basically label it safe. So I have defined thresholds for all of these things. Now, if I come on to the most important part, it's Qdrant. Without Qdrant, this could not have been possible. So why I think Qdrant is basically perfect for this project is that, as you said, we had an edge, then we also have the option to deploy it locally as well as on cloud. So I think that gives us a lot of perspective and ways we can try and experiment, as I did in my demo in a 2D simulator, but then I can also go on and incorporate it into a 3D setting. So to the main basically things which I used to choose and evaluate Qdrant as the best option were that we needed things which were incredibly fast and the ability to filter that search based on metadata. Along with that, I think which is important is that we can have high speed approximate search. Along with that, no overhead for edge or distributed systems. So I think Qdrant helped in that case. Now I have small snippets from my demo. So basically, as you can see, my arrow is on the command side. So basically, I we can use the arrows to basically make a trajectory. After that, we can run it. If in case we have a collision, as you can see, we can basically see that it comes up as unsafe. after we have it as unsafe, we can go in and query the memory. So this basically goes to the Qdrant database, and we can check what were the nearest safest memory which we can use to replace it. So we have some options here now. You can basically execute and see what comes up. And as we can see, we found a better trajectory. Since I was also going towards the right side, so it basically reflected off from the box a little bit. So this is also a memory bank. This basically shows the top 100 trajectories which are stored right now. Along with that, I'm sorry, I think the slide might be a bit off, but I'm also thinking of deploying this in 3D right now, since what I presented was a 2D demo. So what I think is right now, it was built in simulation, but right now we can deploy it on edge within the robot's onboard compute, or we can basically offload it to a companion device or some micro server over Wi-Fi. So we can basically then in each edge deployments run a light Qdrant instance or use an embedded vector search. Along with that, we can replace the simulated 16 ray LiDAR readings with a combination of different readings, which I am planning to do, like camera readings as well. So we can basically also identify what exactly is the obstruction. And then I think when we go in, basically the process of the runtime would be something like the robot's controller streams the sensor readings to the memory layer. A rolling window of the last 5 steps is turned into an embedding, or we can also change this to incorporate more embedding types, and then it's embedded in Qdrant for similar safe search. And then we can basically, in case of collision or something unsafe, we can basically query Qdrant. So this is something I think we can do. I think more than being a sole project, this can combine with reinforcement learning, and also on lower end devices where we don't also have enough compute value or something, we can use Qdrant instead. So that's the gist of my project. Thank you so much for being here.
Yeah, that's perfect. That's exactly what I meant, that it's kind of a replacement. I mean, you can't fully replace, I guess, reinforcement learning, but you can find a way for the devices which don't have the capacity to work in these circumstances. And then with something lightweight, exactly Qdrant Edge, this is an ideal case scenario. So exactly like Roomba. I don't know why I'm talking about Roombas today, because my room needs dusting. That's why I talk about it. Let's be honest. But this is exactly what I would like to see in the devices, say next year or something. I think we're going there, and with a very high speed. And I, in general, excited when I see somebody doing robotics, because this is like agents and robotics. I'm like, I wanted to ask you, you said that it's short memory. So I understand that in reinforcement learning, also here, you need some time to accumulate some learning so it starts working properly. So I wanted to ask you on these thresholds, how would you think long will it take to accumulate enough data to start working well with this vector search solution? And then what happens when it becomes too much memory? So like we have a lot of trajectories. How would you renew this memory, refresh it? What would you keep and what would you try to delete to not offload the system?
I think right now, if you're going by data sets, then if you're going for big tech or something which are actually working on robotics, so I think they do have enough big data sets that if they actually uploaded it and inserted it into Qdrant, it would work finely. But if you're going for our cases where we actually don't have access to real world robots, then I think yes, there is a bit of limitation, and of course that limits us to more of projects which can become POCs later on than something which can be real world right now. I think in the case of what you are saying, to filter it out, the most important thing would be safe memories, of course, and near miss memories. Unsafe memories, of course, we can get it in real time when a collision is happening. But safe memories are something which are reflex actions which directly work. near miss can obviously also be treated similarly, because suppose there's a collision right now and a robot comes here, so it can basically check in that it's already near miss, so it won't collide. So I think these two are the most important to keep. Unsafe can be slowly shoved off if not enough storage is there. But yeah.
Well, this is super exciting. Neil, would you use it for any of your devices? I'm talking only about Roombas here, so maybe you can freshen it up. No, but I think this is it.
I feel like I need it when I wake up in the middle of the night and I'm like bumping against everything in my room, and I'm like trying not to wake up the baby, and I can't turn on the lights. I need to have this maybe combined with Abe's like memory bot, something combined.
Yeah, funnily enough, both of the projects, to me, I mean, they're about different things, and at the same time, they're going in the same direction. We're trying to give our agents physical and game one's memory, and it actually makes sense a lot in the semantic search. I'm also interested, how did you come up with the idea to use vector search? Because people are always were concentrated on reinforcement learning or some mathematical models. Was it like your own, or did you read about it, or is it a trend in robotics which we don't know about?
No, there's definitely not a trend about this, because I actually hadn't seen anything before. It was just a random idea in my head while I was going about, like, what if I use vector search in this? And I don't know how, but you guys avoided it. So I think maybe it can be a trend now.
Because we actually believe that it might work. I don't know if you run any evaluations or you plan to add
Yeah,
them.
I am.
Yeah, but could we talk about the evaluations a little bit before we switch?
Sure. So right now, as it could be like, as I had shown, it was in a 2D simulated model. So I have a small bot. So I basically, it runs through a Raspberry Pi. So basically, I sort of tried to connect it with an external server. And then basically, I did small experiments. They were obviously not high level, like a robot is running and then colliding, but small experiments that if I tell it not to go into certain direction, like if a pen is placed there and it should not go, and if it can trip over it, so if it's actually coming back and doing another reflex action. So I saw that out of 5 times I tried, it worked almost 3 times. So I think, of course, this was a demo, so of course it can be obviously made better. But yeah, I plan to do more experiments on it, and I will keep updating you too.
That would be sick. I would like to see maybe a series where we see the videos of, like little trucks trying to bump into the walls and then starting to drive correctly. And then finally, self-driving cars will be all over the world, because I think for 10 years they are still out there studying them. And yet I am not having my self-driving taxi here in Munich. Talking about Munich, we will have the next person who is based in the same city as I am, and our first place winner. But the most important thing that I forgot to say is actually to thank Sanya, because that was super cool, and I will follow it. And I think everybody is super great here. Once again, I am just fangirling here, but we will have to switch next to fit everybody in. And now it's going to be about Ben. I don't know how to describe Ben's project, because first time I opened it for judging, I was like, hell, what is that? That is impressive. But I understood it as something like a Minecraft kind of looking word for shopping. And what actually got me excited is absolutely non-standard approach to e-commerce, which is still a big, well, interest and pain point of all of us, including in the world of vector search. And also this thinking out of the box, and the bot was done to the level that we all in the team couldn't close our mouth when we were watching. So Ben, it's better if you introduce it yourself so people understand where your mind went here.
Yeah, thank you, Jenny. And thank you as well, Sanya and Abhay. Really amazing projects, and what an honor to be alongside you guys. What you've built is really, really amazing. I suppose the way to sort of think about this project is, as you said, it's sort of trying to push the boundaries a bit of discovery and trying to really do something totally different. It's a bit like when you see these fashion shows and you see people wearing, rubbish bags and so on and walking down the catwalk. It's not meant to necessarily be useful, but it's meant to maybe start a conversation and maybe push things in a different direction. So I suppose that's how I kind of think a little bit about this. So where did this idea come from? Well, first, when I first learned about vector embeddings and vector search and so on, I was just, and I still am, honestly fascinated by the way it works in the sense that you can map these semantic relationships by distance and so on. I think it's really an incredible technology, and really, when you wrap your head around it, it really is something quite incredible. So I wanted to find a way where I could sort of explore that and play with that idea and make it sort of accessible to people, and also try and use some of this technology to find relevant products and find a good recommendation sort of system that works for customers. So with that in mind, first I'll show you what it is and what it does, and then I will talk a little bit then how it works under the hood. So when you see here, you see our trusty friend, the Q-Bert, who is our Qdrant guide, essentially. That's kind of a Q, you can see a little bit there. And then this guy, basically, he's asking you, okay, you're going to go on a trip, you're going to go to, for a weekend away, and he wants to know, basically, or she wants to know, where are you going, and what do you want to do, and what do you expect the weather to be? So, for example, I'm going to put the Alps because that was my inspiration. As Jenny said, also being in Munich, that's something which I find very inspiring. I'm going to put hiking, just it's an easy one, but you could put anything here, mountaineering, let's say. And then the weather here selector, so I could put snowy, heavy rain, for example. I'll put heavy rain for this one, and then my experience level. So I'm just going to put intermediate here. Now, when I click begin, a number of steps will happen. First, actually, let me show you here then the architecture. This probably makes more sense to do it this way. So I hope you can now see this screen. So this is all in the, can you still see it, or yeah?
Yeah, absolutely. We see the very big,
diagram.
interesting schema.
Yeah, perfect. So this is all in the GitHub repo, so you can go and have a look through all this, obviously. So first, that's what we're doing there. We're specifying the parameters. Then what we're going to do is we're going to take those parameters. So essentially this sentence, as per the parameters there, the Alps, intermediate, rainy weather, that then goes to Mistral, and we request from Mistral a set of filters, basically, back for Qdrant. So then we basically show Mistral what the output should be in order to query Qdrant, basically the payloads in Qdrant, to be able to filter for relevant products. And I can show you what those look like here. So this is the Qdrant Cloud instance with all the products uploaded. It's 1,500 products here. And you see basically you have these different filters, so materials, weather conditions, weight, you want like a kind of total weight and so on, sizes. So Mistral will determine based on the temperature and based on where it is and these kind of things, which filters to select. And obviously then the description and everything else provides the sort of embedding model with enough context to be able to recommend a short list of products. And then coming back here, we create those, I think, 3 or 4 different queries Mistral creates, which all ping to Qdrant, returning 60 or so responses each. Then that in total gives us about 230 responses back from Qdrant Cloud, super quick, because Qdrant obviously is super quick. The Mistral part takes a little bit longer, but we get these 230 products back. And then obviously, this is amazing as a shortlist. I mean, obviously, normally you would have much more than 1,500 products. So I think this is where Qdrant and Neo4j, I mean, correct me if I'm wrong, guys, but works super well together, because Qdrant provides the short list basically of products, which would take a very long time to do with Neo4j, and is also a slightly different use case in terms of it's not so much this broad search. And then we send that shorter list of products to Neo4j, and we say, okay, we have now 240 products. Let's really get the most relevant ones. So there we have basically a number of relationships which were pre-mapped with Mistral LLM, which is pairs with, layers under, and trip compatible, basically. I think this is somewhere I could have spent probably years refining, because I think this is like kind of the art, is these two steps really is the Qdrant fetching and the Neo4j curation. I mean, getting this exactly right is takes a lot of time, and rightfully, because you need to map everything properly and so on. But I think as a general first approach, it works pretty well. We then basically rank the results from Neo4j to get the 50 curated products back. And then once we have those 50 products, we do two things. So one is we build a virtual world. And that virtual world is essentially, we take all of the categories and subcategories, and we, as people here probably know, we basically, all of those can be mapped onto a 2D plane and have a certain distance to each other based on the embeddings. So they're embedded, and then those embeddings are mapped onto a 2D plane, basically using UMAP. And that creates a kind of 2D visualization of the distance of all of these categories and subcategories to each other. So you have like gloves closer to hats and so on, which is the sort of 2D representation of the relationship between all the categories. But then what we do is, or I do, is take the categories, put the take the number of products returned from Qdrant per category, and then use that basically to calculate the mountain heights for each of the mountains. So if it's rainy, you should have a higher mountain for umbrellas and accessories and everything else. We're about to see if that works in practice, but generally it does do. So that's sort of the idea. So you have this topography which adjusts basically depending on the products. So now let's go and look at it, and hopefully it works as it's intended to. Live demos always good fun. So here we go. We put everything here. So we're going to go begin tour. So now it's going and doing the first step. Basically, it's going to Mistral. It has also a streaming architecture here. So it's getting back the responses in real time from the backend server as it's going through this whole search strategy. It goes pretty quick through the Qdrant part, but there you can see some of the filters being applied. You can then see here the outcome, which it gets back, and the category distribution. And then basically it's finally calculating the placements and everything else. It's a bit slow at the moment. It's like 10 to 17 seconds. And most of that is actually the LLM calls. The Neo4j and Qdrant is actually super fast. So there's tons that could be done there to optimize this at the moment using quite probably larger models than are required. And then you see the products are then placed onto all of the different hills and mountains. So these are the 50 products, which are the curated products back from Neo4j, which are placed here onto the world. And then the height of each of these mountains then is basically the number of the 230 products which are returned from Qdrant. And then basically this, if you put it in this view, you can kind of see the 2D mapping on the UMAP plane of the different things. So that's sort of the flow, and in parallel, there's this request to Mistral LLM as well in parallel to take those 50 products and to get our friend Q-Bert to give us a guided tour of 7 of those products with different steps here. So for example, here he's talking about you need this because it will keep you dry and comfortable even in heavy rain and this sort of thing. So then that basically then just takes you through the different products on a little kind of guided, curated tour. So that's it. It was the hardest part was working with the sort of 3D modeling, which is something I'd always wanted to try and do something in, but like was the first time really doing something proper with it. So it was really a lot of steep learning curve with 3JS and trying to figure out all this different stuff and the dynamic nature of the world. And I think I probably spent more time than anything trying to get the edge of the world kind of flat, and also getting the river to basically generate dynamically every time was probably the 2 hardest parts on the front end side. But I think, otherwise could spend more time obviously working on the curation as I said, all of that sort of step is such a rich world, and Neo4j plus Qdrant. I mean, you can combine them in so many different ways to tweak that. So yeah, but that's it, and yeah, happy to take any questions.
I actually have more. Oh, you see, I was first.
Go.
I have more. I have a comment than a question, because this time you mentioned a lot Neo4j plus Qdrant, and you at some point said, like, you may correct me if you are connected well, and we're actually connected pretty well. We do a lot with Neo4j guys, and we have several videos on the same channel that you're watching the stream from, on the YouTube one, with my amazing colleague Terry, especially who likes to work on this collaboration, where we firstly explore how this can be connected in the best way together. And also we had one case study with legal AI startup, which Letria, which used both Qdrant and Neo4j. You could watch a webinar on that, and there guys actually go in depth on optimization, because even though in your example it's very, very fast, there is still obviously room for improvement because we never stop. So the guys talk about challenges on how to combine together graph and vector search, because both of them make sense separately and in combination. And here from the comment, I'm coming to the question, actually about making sense in this combination. How did you decide that you need both graph and vector? Or was it more to try out everything hypey out there, or is it the true need in e-commerce from your perspective?
I think it's that Qdrant's amazing at the sort of long list, but what I wanted to do, and I think I still, as I said, could have spent more time doing this, is that you often get a sort of long list of products or relevant products or stuff which obviously you might want to scroll through or explore in this world, for example. But the goal was to find a way to take that long list and kind of make sure that the products actually match with each other and that there's some kind of relationship between them. So that was sort of the idea there, was to say, okay, we're going to have like a lot of products. They're going to all be relevant to the user in some way because based on what they want, or you could have also added personalization to say it's relevant to this particular user as well. But the idea was then to say, on top of that, can we basically curate this into like a list where the combination of those products sort of makes sense? And I think I kind of took two different approaches of doing that, kind of sequentially, first curating via Neo4j and then taking that list and curating via an LLM. I don't know if that is the best way to do it. I would have wanted to spend more time kind of playing around with that mix or through that sort of three-step process from Qdrant to Neo4j to the final LLM call. But I think that probably, in my head at least, there was some sort of logic of finding more the relationships between products with the graph search and finding more the long list and the relevancy with the vector search.
Yeah, I think it's actually a very powerful combination. I saw a lot agentic instruments and in general search applications, modern ones, combining both of them. I actually, funny enough, I worked at some point with a graph database and graph search, so I've seen them all. And it's super relevant, especially in e-commerce. So I was happy to see this combination. I think you also won the Neo4j award, so you collected all of them. Yeah, right? Yes.
Well, for that,
yeah,
bonus Neo4j and the grand prize Qdrant prize as well.
Yeah, thank you very much.
And it's super actually interesting, also another comment, to see that the second application where filtering on vector search makes a lot of sense, as it was with Sanya, as it was with you. That's why I think, also correct me if I'm wrong, you selected Qdrant, guys, because we have filterable HNSW, because vector search with filters is not that good usually. But we have our own customization, which makes it actually pretty fast. It was talked about.
Yeah, and I think that was actually really cool to use the LLM to choose the filters as well. I think that actually works surprisingly better than I thought it was going to like do it that way around almost. Because often it's kind of to feed an LLM, but to get the LLM to use the filters, I thought actually works surprisingly quite well.
Yeah, I think it's just a totally wild project. I saw it and I was like, whoa, what is going on here? And every time I look at it, I'm finding like new things. Like I just saw when you were presenting now, there's like a little bug or bird flying through it, and when you were configuring it and you were changing like the weather, the background was changing. I was like, I didn't even know that was happening. There's just so much attention to detail, and I want to throw some of the comments on from the audience for you guys to see. They're getting lots of congratulations from the audience here, and when you hackathon winners to see the congratulations coming in from everyone viewing today. And yeah, really great project. So round of applause for our hackathon winners today. And thank you so much for participating in this showcase. Any other questions from the audience? Feel free to put in the chat. And anything else, Jenny, that you want to ask our hackathon winners today? I know we're kind of running up on time. We're got like maybe 3 minutes left in this slot.
I think what's important is that if you guys have any specific means for people who are going to look at your GitHubs and try to learn from your doings, what would be the best way for each of you to answer questions if people will have any? So say, Abhay, for you, it would be GitHub issues or LinkedIn. What would you prefer?
That would be LinkedIn, yeah.
LinkedIn. Okay, then.
Yeah.
Okay, perfect. Then we're going to have all the links in the YouTube, but we also have it in our messages, which we're advertising this live stream. All in all, I think it would be very easy to find you. What about you, Sanya? Also, issues, LinkedIn?
Anywhere, I'll be there for you.
Ben, what about you?
Yeah, LinkedIn, also great.
Perfect. And then the one last quick question for each of you. What would you dream? I know this is such a like a pin glasses question, but I really want for you to also dream about it a little bit, like, as broad as it gets. So what would you see the best outcome of this project, besides, of course, winning the Qdrant hackathon that already happened? Like, what goes further? And let's start once again from you, Abhay.
I think I would love to see, for example, when I'm playing a game and let's say I have a companion, then I can just instruct him or her to go at some point and point again to a specific location and wait for my order. Yeah, so basically human-like NPCs. That's what I want to build.
Okay, so you're humble. You just want people to have it there in all the games. You started it,
Yeah.
and it will continue and get on. Perfect. Sanya, for you, what would be that?
I think for me, I would like more of multimodal embeddings in robots. Like they know what exact obstacle it is, so they can avoid it next time, and also recognize the location where it was. So I think that's something I also want to work on.
Perfect. And actually, Qdrant supports multi-embedding, so we can talk about it out of the box. And Ben, what are you planning to collaborate with Minecraft? Tell me.
Actually, I've never played Minecraft, which is a bit embarrassing. But I know what it is, and I know what the aesthetics are. But I never actually played. I think I'm a bit too old to have played Minecraft at this point. I played other things.
No, don't say it. What if our audience?
Maybe I can't say that. Maybe that's yeah. You're never too old. But I just want people to try new things. I just think it's cool to just try and do something different from a list view and a search bar. I think it's just it's incredible how many millions of iterations of that exist, and maybe it is just the best way, but maybe there's also other ways we can try and do search and discovery and try and inspire people. And this is probably not it, but at least it's something a bit different.
Awesome. Well, we have about 30 seconds before this stream cuts us off, so I think it's best that we wrap up now. Thank you guys so much for joining us today again, and thank you all in the audience for tuning in. We will see you next month, November 12th. We're going to have Arise AI join us for a special session. We'll post more details on that on LinkedIn. And you all have a great rest of your week. Thank you.
Thanks for
Bye.
having us.